Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Let's have a discussion on the past year question. Have a look at this question. Question of the year 2010. May-June paper, variance 41. Have a look at the question here. The particles A and B of the masses 0.2 kg and 0.45 kg. So I'll label it first. 2 kg means 2 Newton. And for the particle B, 0.45 kg means it's 4.5 Newton. So they are connected by the string of the length 2.8 meter. That means the whole string here, the length is 2.8 meter. And the string passes through a smooth pulley at the edge of the rough horizontal surface. So when they mention it's a rough horizontal surface, that means there is a friction, which is 2 meters above the floor. So it's indicated here in the diagram. And the particle A is held in contact with the surface at a distance of 2.1 meters from the pulley, here. And the particle B hangs freely. So you're asked to see the diagram. So all this is actually just to describe the diagram. And now the coefficient of friction between the A and the surface is given by 0.3. So now, particle A is released and the system begins to move. So for the part 1, you are asked to find the acceleration of the particles and show that the speed of B immediately before it hits the floor is 3.95 meters per second. Correct the 3 significant figures. Alright, so let's solve for the first part. How to find the acceleration of the particles? Both the particles are actually connected, so they should have travel with the same acceleration. So for this kind of question, it's actually standard. It's a standard question. How to find out the acceleration? You just need to form 2 equations. So for now, let's say have a look at the particle B. Which equation to form? We're going to form the equation by using F equals to ma. Have a look at the particle B here. When the particle A is released, this pulley, this system will actually move in this direction, which means the particle B will actually go downwards, and the downward force should be higher than the upward force. So what are the forces that act on the B? So the downward force is actually 4.5 Newton, and the upward force should be the force in the string, which is the tension. Let's form the equation for the particle B now by using F equals to ma. Since the B is moving downwards, that means the downward force is actually higher and stronger compared to the upward force. So to form the equation, it should be the downward force minus the upward force equals to ma. So in this case, it should be 4.5 Newton minus the tension in the string equals to ma. The m is 0.45a. That's the equation for the particle B. Let's form another equation for the particle A by using the same equation, F equals ma. For the particle A here, is moving in this direction and is being pulled by the tension towards the right hand side. And what about the forces towards the left hand side in the opposite direction? There is a frictional force. Okay, so for this case, since the particle A is moving towards the right hand side, which means the right hand side force is actually higher and stronger compared to the left hand side force. So to form the equation, it should be tension minus friction equals to ma. So the tension, we leave it here, minus friction. Okay, how to find friction? Remember in the previous chapter, friction should be equals to mu r. So the mu in this case is given here, 0.3. And the r, okay, what's the direction of the r? The r should be in this direction. So for here, r should be equals to 2 Newton. And equals to ma. The m is 0.2 a. So what you need to do now is just to solve this and this equation simultaneously, and eventually you will get the acceleration equals to 6. That's how you solve for the first part to get the acceleration. If the question asks for the tension, you just need to substitute the A into one of the equation to get the tension. Usually when it comes to the Pulley question, the first part they always ask for the tension or the acceleration. Alright, so to answer the second part, they ask to show that the speed of the B immediately before it hits the floor is 3.95. This is what you need to show. Have a look at the B here. The B dropped from this point to the floor, and you are asked to find the final speed here. So for the B, it's released from rest, so U should be equals to 0. And the acceleration for both the particle A and B should be the same, which is 6. And how much B has traveled from this point to this point? B should move from here to here. Remember just now they mentioned that the length of the string was 2.8 meter. So in total, the length here is actually 2.8. So 2.8 minus the 2.1 here, which means in this part is 0.7. So in total, here is 2 meter. In another word, it means for B to travel to reach a floor, it's 1.3 meter. So the S is 1.3. And you are asked to find the V, the final speed, when it hits the floor. So you just need to use one of the 4 formula. So for this, you have to use V squared equals to U squared plus 2AS, which is equals to 0 squared plus 2 times 6 times 1.3, which is equals to 15.6. So the V should be equals to 3.95, correct to 3 significant figure here as mentioned. That's how we solve for the part 1. For the part 2, given that B remains on the floor, find the speed with which A reaches the pulley. So for the part 2 here, it's something very common, the common question in this chapter. Whenever they ask about pulley question, they'll ask about this question. So how to find the speed of the A when A reaches the pulley? So have a look here. When the B reaches the floor, when the B traveled for 1.3 meter, means that A will travel for 1.3 meter as well, because they are connected, and reach this point with the same speed, which is 3.95. And the distance traveled here is 1.3. In another word, to reach the pulley, the distance that A needs to travel is 0.8 meter. For pulley question, you need to know about 2 terms. One is called taut, the other one is called slack. When the string is taut, it means that the string is very tight, means there is tension in the string. But when the string is slack, means that it's loose, which means that there's no tension in the string. Let me move this somewhere else. Alright. Have a look at this question. Initially, the A and B were connected by the string. And for the first part, when the B reach a floor, and the A will travel the same distance to reach this position. For the first part, the string is called taught. And for the second part, when the A has reached this position, and when it moves further to reach the pulley here, the string becomes slack. So you need to take note here for this question, there are two parts. One is taught, one is slack. So now, for the slack part, we know that the initial speed is actually 3.95. So the final speed just now when B reaches the floor is equals to the final speed when A reaches this point. So now when we are looking for the slack part, the final speed just now becomes the initial speed when it's slack. So the first thing to take note in this question is the final speed when it's taught. Okay, I should write it as the final speed when it's taught is equals to the initial speed when it's slack. This is the first thing that you got to take note. And then the other thing that you got to take note is when it's slack, it no longer travel with the same acceleration. It should travel slower. So we need to find out the new acceleration when it's slack. So this is the second thing that you got to take note in this type of question. You got to find out the new acceleration when it's slack. Okay, so let's try to do this. How to find out the new acceleration when it's slack? You just need to look back at the equation that you formed earlier in the part 1 for the particle A, which is this equation. So for this equation, when now the string is slack, it means that there is no more tension in the string. So what shall we do to this equation? We just put back the same equation, t minus 0.3 times 2 equals to 0.2a. This was the equation from the part 1. So for now, since we are looking for this part, the A is moving towards this side with the string slack, which means there's no more tension in the string. So we need to substitute t equals to 0, zero tension in the string, to find out the new acceleration. So we'll have 0 minus 0.6 equals to 0.2a, and hence the A is negative 3, deceleration, which means the particle A goes slower and slower to reach the pulley. So for now, we can eventually find out the final speed when A reaches the pulley here. Okay, so let's make use of the information that we have. We have here, according to here, the U is 3.95 and the distance traveled is 0.8. Let me highlight this. The U is 3.95, distance traveled is 0.8, and the A is negative 3. And hence, we can find out the final speed by using the formula V squared equals to U squared plus 2AS. So the final speed should be equals to, okay, U squared. The U squared should be 3.95 square, which is the same as the exact value here, 15.6. it's actually better to substitute the actual value rather than the rounded up value from the part 1. Plus 2 times the A is -3, the one that we just found out, the new acceleration when the string is select, and the S, the distance traveled to reach a pulley, is 0.8. And eventually we'll get V equals to 3.29. This is how we solve this question.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.